My name is Marc Jellinek, and this is deploying and developing Azure solutions using modern cross-platform tools. What we're going to do today is we're going to get hands-on with tools like PowerShell, the PowerShell AZ module, ARM templates, ARM template parameter files, yada yada yada, and we're going to be pushing out a solution that actually works. So what are we building? We're building a process that's going to populate an employee dimension in our enterprise data warehouse. Now we're planning on merging changes in from the source system. Our source system doesn't keep track of changes, but our data warehouse needs to. So we're going to do a slowly changing dimension type 4, backed up by a SQL Server 2016 or higher temporal table, and that will maintain our current state and dim employees and our historical state and dim employee history. Our source and our target tables are both in Azure SQL databases, and we're planning on orchestrating this all through Azure Data Factory. So now that we know what we're building, what tools are we going to use to build it? There is two great open source cross-platform code editors. One's Visual Studio Code, the other is Azure Data Studio. These run on macOS, Windows, and Linux, and just really amazing tools. Azure Data Studio, I think, is poised to replace SQL Server Management Studio as my new happy place. Other things that we're going to use resource manager templates and parameter files to describe the things that we're going to deploy. All of our deployments will be handled through Azure PowerShell, the AZ module. All of our interactions with databases will take place with SQL files. We'll use the Azure portal to monitor, and we'll use the Azure Data Factory portal to look at our pipelines and trigger them off. Now that we know what we're doing and what we're doing it with, what order are we going to do them in? Our first thing is we're going to deploy a new resource group, and this gives us a deployment boundary. It also means that when we're done, we can drop the resource group and all of the resources within it are dropped also. We're going to create a target database, a source database, and a data factory, and then we'll populate the data. We'll populate the databases with data, and we'll populate the data factories with a pipeline. At each step, we're going to validate our assumptions. We're going to make sure that what we expect is what we get. So the first thing we're going to do is we're going to jump into Visual Studio Code, and we're going to deploy our resource group. Some things, if you're running this alone, you're going to want to change the subscription name, the resource group name, and the location, so that when you connect to Azure and create the resource group, it'll be closer to you and it will reflect the resource group and the subscription name that you're using. Now, if you're doing this on Linux, you're going to be prompted to do a device login, so just copy the authentication code, go to your device login, and pick your subscription. And our resource group has been created. We can confirm this by going into the Azure portal, doing a quick refresh, and there's the resource group that we created. Now that we have our resource group deployed, we are going to deploy our source database, our target database, and our data factory. We just want to take a quick look at the parameters file that's associated with the deployment. We're going to be setting the admin user to demo admin. We're going to be setting the admin password, and we're also going to be changing the last name. This is used in naming the data factory. And these parameters are passed in. Now this is good for a demo, but in real life you would have a reference to an Azure Key Vault, and then you would reference secrets within the Key Vault. This means you don't have passwords in your parameters files. That's something that's not desirable. So when we do our deployment, we're looking at 0010 deploy source and target database. And in here we have parameters that are going to be passed in. And then we describe what we're going to be deploying. Right here we're going to be deploying a data factory. Here we're going to be deploying an instance of SQL Server. And on that SQL Server will be a database called Source Database. And then we're going to deploy a second server with a database called Target Database. And we do all of this by loading the PowerShell script. And there are a couple of things that we're going to capture. In the template, we have output parameters, source database name, target database server name, and data factory name. And these are going to be passed back to these PowerShell variables. The source database server name is a GUID. It's generated at deployment time. And the target database server is also a GUID. And then in the data factory name, a component of the name is a GUID. The reason we're using GUIDs for naming is these have to be globally unique. And by globally, I mean throughout the world. And by generating the GUIDs, we can assure that. The PowerShell script does take a little bit to run, so just be patient. But notice our outputs, our source database server name, our target database server name, and our data factory name. And we can confirm that these have been deployed by refreshing the contents of the resource group, and we can see servers, databases, and a data factory. Next, we're going to populate our source database. We see here that we have a table that is created, DBO employees. This is going to be our source of our data. And then in here, we are inserting 100 rows of test data. So all we've got to do is execute the query against the source database. And we see that we've loaded 100 rows of test data. Next, we're going to deploy our target, and this is our data warehouse. So we're going to execute this against our target. And we've completed that. So one of the things I'm going to do is I'm going to show you Azure Data Studio. I'm going to capture the source database name, and I'm going to connect to our source. You just add .database.windows.net after the GUID, and then you log in using the admin user account and the admin password that were set in the deploy database. And in our source, we see that we have the one table, DBO employees. Now we're going to connect to our target database, and we're going to grab that right here. Again, adding .database.windows.net. And this is our target database. And in our target database, you'll see that we have dim employee listed as a system versioned table. This means it's a temporal table. And if we drill into that, we can see that we have history in dim employee history. Also a very important table, our audit operations event log, and this is what we write to every time we do something so we can keep track. Now, prior to populating the data factory, we have to tell it a couple of things. We have to tell it the data factory name, which was output when the data factory was created. We have to tell it where the source database is and provide a connection string. And the same thing, provide a connection string to the target database. Once that's done, we can open up deploy data factory.ps1 and execute it. And this executes fairly quickly. And once that's complete, we can go into the portal and start to explore our data factory. So now that we've populated the data factory, let's go into the data factory in the Azure portal. Click on Author and Monitor. And you'll see that we have connections to our source and target database. We have data sets that represent our source and our destination tables, and then a pipeline that orchestrates the entire process. Going through this pipeline, we log that we've started the sync, we log when we end the sync, or we log when there's an error. But the real work is done in this copy data activity, where our source is the table DBO employees in our source, and our sync is our target dim employees. But notice that we're loading into a stored procedure called load employee, and we'll see that in just a second. But the stored procedure is provided with a table type parameter called employee, which has the source data. Once we have that, we call load employee, and we see that we're passed in a parameter that represents the source data. We write a log message saying we're going to start. We are going to merge using the table type parameter as our source, and we're going to merge into dim employee. We're matching based on keys, and when it's matched and something has changed, update it. If something is not matched, it doesn't exist in the target, insert it in the target. And if it does not exist in the source, but it exists in the target, delete it from the target. And then we write to the operations event log that it is successful. So let's take stock of where we are. We have our source database, we have our source table, DBO employees, and we're just going to do a quick select star from dbo.employees. We're really enjoying the IntelliSense experience, and we see that we have 100 rows of source data. In our target database, we have our target table, dim employee, that has no data in it, so we're starting off clean. Now the whole purpose of this process is to run a detection that will pull from the source database and write to the target database. That is handled by our data factory. So we're going to trigger the data factory and watch it run. Once we've triggered it, we go into the monitor and we see that we have a pipeline running. It's already done the log. It is now working on the merge. And just to warn you, this does take a bit. So let's pause here and see what happens. Oh, it succeeded. We see that we had 100 rows written in our source. We had 100 rows written to our destination. It took 3 seconds to run and used 4 DIU, data integration units. And this is important because it is a component of what you are charged. So let's see what we have now in our target database. We have 100 rows. You know, I already have a query written for this, so we are going to query the target table. We are going to connect to the target database. And we are going to see that we have 100 rows in dim employee, which we expect. We have 0 rows in employee history, which means everything is new, nothing's been modified yet. When I take a look at the entries in dim employee, I see first names and last names that look like they reflect the data in our source, so that has been successful. Now we're going to last take a look at our operational event log, and we see that we have 4 entries, and those 4 entries say start of the sync, start of the load. We see that we have a source row count of 100, which we expect. We finished the load of dim employee and we have finished the sync. Everything looks good so far. Now what we're going to do, because we do have to capture changes in the source database, we are going to connect to our source database. And we are going to delete employee 33. We're going to insert a new employee. And we're going to update employee 66. So let's get that running. We have 3 affected rows. That is what we expect. Now let's run the pipeline again and see if it picks up the changes. So we trigger the pipeline. Go back to the monitor. It is running. And this takes a minute or so. And we see in our copy activity we had 100 rows in our source, which is what we expect. We deleted one, but we inserted one. 100 rows written to our sync. Took about 4 seconds, and again used 4 DIU. So let's take a look at our target and see what landed. Well, it's 100 rows in employee that we expect. 2 rows in history, we changed 33 and 66. And we take a look at our operational event log. We have 4 new events. started the sync, source of 100 rows, finished the load, finished the sync. So far this is tested out successfully, and based on that success, I deployed this solution to our test environment. Now when this was deployed to our test environment, we got results that were not easily immediately understood. For example, the table dim employees had only 20,000 rows in it, and the employee history table had about 480,000 rows on it, so definitely not what we expected. So the only difference between the source table DBO employees in my unit test was it only had 100 rows, where DBO employees in our test environment has 500,000 rows. So what we're going to do, we're going to insert 500,000 rows into our source and see what happens. We open up the file, 500,000 rows. We connect to our source database. That's going to take a bit to run. We're going to pause here for just a second. And the query has completed. We see that we now have 500,000 rows in DBO employee. So our next step is to trigger the pipeline, let it sync up, and this will take a bit. So once I get into the monitor, we'll be back as soon as this is complete. And we see that the data pipeline is now completed, and we go into the details of the copy task. The source was 500,000 rows. The target was written 500,000 rows. Still using 4DIU, and this time it took a little over 5 minutes to run. Now let's take a look and see what we have in our target table. This doesn't make any sense at all. We have 20,000 rows in dim employee. We have 480,000 rows in employee history. As I take a look at dim employee, I see that there's definitely chunks of data missing. There's, a couple 100,000 rows there that are gone. I want to take a look at my operations event log and see what happened. I was expecting 4 events, but it looks like I got more than that. And anything higher than 8 is new. And we see that our row counts are not 500,000, but instead Azure Data Factory broke this up into multiple batches with less than 500,000 rows each. So we've learned something. When pushing data to SQL Server as a stored procedure sync, Data Factory will break up the source into batches. These batches will execute serially, one after the other, and then the merge in the stored procedure load dim load underscore employee. It assumes that it has a complete data set, and it needs a complete data set in order to work, but it was handled partial data sets. So we need to find another solution. So what does our alternative look like? Well, I think we should keep a stage table that holds the source data, maintain that stage table using a trunk and relocate a truncate and reload pattern. And then after loading the stage table, we use that as the source for the merge. So to accomplish our task list, we're going to create our stage table in our target database, and we're going to execute this against the target. And that takes a couple seconds to run. And then we're going to update our stored procedure load employee, and this is also run against the target. And we're good. And now we're going to update the data factory. I put the data factory definition into an ARM template, just same way we've always done. And then all I've got to do is call my PowerShell script that calls the Azure Resource Group deployment. And we'll see that our parameter file is a parameter file that we used earlier. These can be reused. So we deploy that. And again, takes a couple seconds to run. And once this is completed, we can go back into the Data Factory portal and we take a look at our pipeline. Our pipeline is now much more involved. It's a lot of logging. We log the start, we copy from source to stage, we log success or failure. After we've copied to stage, we call the stored procedure to merge. We log success or failure, and then we log that we're done with the sync. So now all we have to do is trigger it. Go into our monitor. And it's currently running. Now remember, we've got 500,000 rows in our source and we have 0 rows in our destination. I zeroed out the target databases so that we could start fresh. We'll be back as soon as this is done. And we see that our data factory is now completed. We go into the copy task. We see that our source was 500,000 rows. 500,000 rows were written, executed in 33 seconds, which is a considerable improvement over the stored procedure sync, and our throughput was also significantly higher. So let's take a look and see what landed in our target database. We have 500,000 rows, which is what we expect. 0 rows in history, and I'm very interested to see what our operations event log says. We have 6 events, which is what we expect. Started the sync, copy from source to stage. We're now doing the merge, and our source row count on the merge is 500,000, so that's exactly what we expect. We finished the load, finished the merge, finished the sync, and we're good. So far, this looks good. Now, let's make some more updates to the target database. And we'll run the file 0110 update source database again. And you'll see that we are deleting employee 1024. We are updating employee 512, and we are inserting a new employee. So we've got to run this against our source. And we kick off the pipeline, what we hope is one last time. Go back into monitor. And I will see you in approximately 2 minutes. Alright, we see that our pipeline completed. Checking the copy task. 500,000 rows in source. 500,000 written to destination. 35-second runtime. Pretty good. Now let's check and see what landed in our target. 500,000 rows, 2 rows in history, and we see that it's source key 512 and 1024. The rows that we modified, that works. Let's go down to our operations event log. Anything over 7, we start the sync. We have a row count of 500,000. We finished, and we got what we needed. So to recap, what we've delivered is a solution that will populate the employee dimension in our data warehouse. We're going to merge changes from the source system into our dimension table, detecting changes as the source system values change. We're going to use a temporal table to create and maintain a slowly changing dimension type 4. We're going to keep the stage table as a source for the merge. Our source and our target tables are in Azure SQL database, and our orchestration is provided by Azure Data Factory. We were able to deploy and manage this completely using ARM templates, ARM template parameter files, SQL files, and a little smattering of PowerShell. I hope you enjoyed this. We've been successful, and have a great day.